Hey everybody, this is a 9.3 overview video real quick. I just wanted to point out some things in 9.3 to help you learn some covalent naming systems. And then we're going to go over an introduction to that next activity that you're going to have to do. So first off, why do we need a different naming system for molecular or covalent compounds versus the ionic naming system that we already have? Well, I'm going to use this example, even though it's also at the bottom. Remember, in ionic compounds, we just name that first element and then we name the second element and change it to "ide." So this would be carbon oxide, and this would also be carbon oxide. Ions can't really form more than one compound together because their charges have to balance. So there's a set ratio. But when we're sharing electrons, this often happens. There's more than one way to combine. So we need to have the number of each atom in the name of the compound to differentiate them, because this one's super toxic and this one's not. So we need to make sure that we can name them differently. So we're going to use these prefixes, and these are all in your book: mono, di, tri, tetra. We see that again after our tetrahedral from chapter 8. Okay, and then we get all of our regular, more geometric prefixes after that. So make sure you memorize those, and that helps us differentiate between carbon monoxide and carbon dioxide. Please also note our second element will still end in "ide, and it always has a prefix: monoxide versus dioxide. The first element will have a prefix if it's more than one, but it won't have a prefix if it's only one. So make sure you remember that. We don't ever start a name with mono, but the second element will always have that prefix. On the next page, there was one example that I put into our notes packet: our tetraphosphorus trisulfide. When you're writing a chemical formula for a covalent compound, you get to take it literally. Tetraphosphorus means 4 phosphorus, so P4. Trisulfide means 3 sulfur, S3. So P4S3. We don't have to do a switcheroo. We're not doing any math. We just take it as it is. If we look at our lesson check, they asked you to do a lot of practice with this. So for example, part A on number 30 would be nitrogen trichloride. If we skip over to part E, dinitrogen tetrahydride. So yeah, hydrogen becomes hydride when it's that second element. And again, that first element gets a prefix if it's more than one. So dinitrogen versus just nitrogen over here. Okay. When you are, again, writing their chemical formulas, you just take it straight up. Don't switch anything. Phosphorus is capital P. Pentachloride is Cl5. It's 5 chlorides, so Cl5. PCl5 would be part A there. So work on those if you haven't gotten them done. Make sure you fill those in. And then I want you to take out the worksheet, molecular and ionic names and formulas. And from your notes packet, copy in here the 10 prefixes that we just listed in your notes packet. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Write those in so that you have those to reference on here. Okay. When we look at the next 2 little sections of this worksheet, these are all covalent. So you're going to be using those prefixes that you wrote up here to fill these in. Careful on number 5. Number 5 is a carbon and 4 iodine bonded to each other. So if we were to name this one, this would be carbon. Remember, we don't start with mono, so just carbon. And then tetraiodide. We still end in "ide." Tetraiodide. Carbon tetraiodide. Down here, again, very straightforward. Just write exactly what it says. So if this one says dinitrogen, that's 2 nitrogen, N2. Tetrabromide, 4 bromides, so Br4. Okay, this is the piece I really wanted you to do with you guys. So ionic, if we're looking at clues if we just have a name of a compound, we can look for clues in that name to tell us whether it's ionic or covalent. And the easiest clue has to do with all these prefixes that we see up here. Okay, ionic compounds have no prefixes. That's the easiest way. If you're looking at its name, no prefixes means it's ionic, and prefixes means it's covalent. That's the easiest way. There's other ways, but that's the easiest one, okay? If you're looking at a chemical formula, so if I gave you N2Br4 and I wanted to know, is that ionic or covalent? The easiest way for a chemical formula is an ionic starts with a metal, or NH4. So it either starts with a metal or it starts with NH4. Remember, NH4 is ammonium, and that's one of the polyatomics we memorized. It's our only one that's positive. So it either starts with a metal or it starts with ammonium. Okay, it might not necessarily be in parentheses, but it'll start with NH4. Covalent, all of our covalent compounds on this activity are going to be two non-metals. Two non-metals. It's covalent. So turn the page. We'll look at the first two here. Number one says potassium chromate. Again, we're looking at a name. There's no prefixes in this name, so it's ionic. Number two says phosphorus pentafluoride. Well, penta is a prefix, so this is covalent. So you can do that all the way down. Look for prefixes. Prefixes are covalent, no prefixes, ionic. Potassium chromate. Well, potassium's a group 1 element, so it's a 1+ charge. Chromate is one of our flashcards, so CrO4 2-. So those are my ions. So the formula of the compound is when I take these and I mathematically create our neutral compound. So I bring that 2 down, bring that 1 down. We don't have to write ones, but I get K2CrO4 as my answer. So it takes a little bit of work to make that formula for an ionic compound. For a covalent, it takes a lot less work. Phosphorus. If I don't know the symbol for phosphorus, I look it up on the periodic table and I find P. Pentafluoride. Penta means 5. Fluoride is fluoride. It's F. So I look at the periodic table. I have 5 Fs. F5. So PF5 is it. I don't have to do any switching or any mathematical thinking. I just write exactly what it says. Okay, flip it to the last page. We're going to look at these last two. So again, if I am given a formula, I just need to look for whether it starts with a metal or ammonium or not. Okay, this is just two non-metals. So this one is covalent. Copper and phosphate. Copper is a metal, so that's ionic. Okay, ionic are a little bit easier to name. We just name the cation, name the anion. So Cu is copper. It is a transition metal, so I'm going to need a Roman numeral, which we'll figure out in a second. PO4, this entire thing right here, is phosphate. And if I look at my flashcards, phosphate has a 3- charge. So that means if I have 3 coppers to balance out a 3- charge, my copper must be a 1+. So that means its Roman numeral is a 1. Don't stress too much about the Roman numeral part. As long as you're knowing that it's ionic and you're not putting any prefixes in here, you're getting that right. But our covalent, remember, you need a prefix. You need prefixes on the second element every time. You need a prefix on the first element if it's not a mono. Okay, so this one is going to need a prefix. We need hexasulfur. And then we have 8 on the fluoride, so octafluoride. So good luck with the rest of the packet, and make sure that you remember to submit that when you're done. Thanks.